Welcome back to PLS 510. Today we want to talk about one of the major grasses in Kentucky. In fact, the major grass of the southeastern United States, tall fescue. Scientific names are important to function well in the real world, and perhaps the next thing I'm going to tell you and maybe explain why. Tall fescue has had a variety of scientific names starting 30 years ago. Fescue arundinaceae. Actually, recently, I'm going to massacre the word, but Shedonurus arundinaceum. And then the current word, or current scientific name that we will use and refer to as tall fescue is Lolium arundinaceum. And if you may remember that Lolium is actually the genus of ryegrass, and may help you understand why ryegrass can be confused so easily with tall fescue. In fact, they can be crossed and come up with a different species. So, tall fescue. It's a perennial and erect, tall-growing grass, and the picture to the left is an awfully good representation. It is a bunch grass, even though it does have short rhizomes. These rhizomes don't grow rapidly enough to make a sod like bluegrass does, but they do have short rhizomes. Used as hay or pasture and adapted to most of the eastern U.S. Let's talk about some identifiable features. It's important that you know how to be able to identify tall fescue, at least where you expect to find it, because that you're going to be asked, in my mind, a lot of us are going to be practicing agronomists, maybe even practicing forage agronomists when we leave here, finish this course and graduate and go on. And you're going to need to know the kinds of species that you're seeing if you're walking a pasture or hayfield with a client. So let's take a look at some of these features. If you take a look at the vegetative tillers, right, that's that stage after seed germination and before stem elongation, you're going to see that the bud orientation is rolled. In other words, they have round tiller bases. When that leaf emerges from the leaf below and sticks its that leaf blade out, it's going to be rolled. Contrast that to orchard grass, which comes out very flattened in half. The ligule, which is that structure right where the leaf sheath joins the leaf blade, and then we call that region the leaf collar. The ligule is small and membranous. The auricle is blunt to claw-like, and we'll see pictures in just a few minutes. Other features that are characteristic of tall fescue: very prominent veins on the leaf blade. The edges of the leaves have fine serrations. If you hold the leaf tip and run your fingertips back from the tip to the base, it'll feel like a fine-toothed saw blade. The midvein is not very prominent most of the time. The leaf tends to be flat, and it also tends to be shiny, sometimes shiny, very shiny on the bottom. Tall fescue can be coarse and erect, and it can with broadleaves, or it can be fine-leafed and lax in leaf structure. That is, the leaves are falling over. Here are actually three photographs of tall fescue that help you see some of the characteristics. If you look starting on the vertical picture on the left, you can see the prominent veins, the sheath, the collar area, and the midvein does show here pretty prominently on that picture to the left, at least on the bottom of the leaf, but not very prominent on the top. If you go to the bottom right and take a look at that leaf, you can see those prominent veins, and you can see very easily very well how that leaf comes out, emerges from the sheath of the leaf below it, rolled up. And a close-up there of that leaf collar, leaf sheath, leaf collar, leaf blade region. You can see just a hint of a ligule back there, right, laying up next to the rolled up leaf that's coming out and emerging. But these are the auricles that come around that leaf that's coming up, or the part of the plant that's elongating right through there, we call them clasping auricles. That's the way these look here. So that's tall fescue. Some other views of tall fescue. Again, this picture on the right, very good picture of the prominent veins, and in fact you can see along the leaf edge those serrations. The picture to the bottom left shows how rounded it can be. The ligule there is quite large, and the auricles are clasping. And then you can see another tall fescue blade on the upper left. I'm going to make the point that tall fescue has a lot of genetic variation in its DNA, and that means it can have a lot of different phenotypes. That is, it can look very different from plant to plant. If you were to compare the size of the ligule between the plant in the middle and the ligule here at the plant in the upper left, it's very different. However, they're both tall fescue. Fescue does have a small membranous ligule, and that's a close-up of that. This slide is a close-up of the picture from the page before. You can see that it's very small. And of course other fescue plants can have somewhat bigger, but it is this prominent leaf veins and the lack of a prominent mid vein, the shiny leaf, the coarse nature of the leaves that are characteristic of tall fescue. And you can see those serrations on the leaf edge. Tall fescue originated in Western Europe and Northern Africa, the humid regions of Northern Africa. We're not sure exactly how it was introduced to the United States, but believed to be in the 1800s. The most significant find of tall fescue, and that's how we develop varieties, we collect seed or plants that look desirable and cross them, and that occurred in Kentucky, Menifee County, which is just south of Mount Sterling. The county seat is Frenchburg. It was discovered or found, or at least found by somebody who was going to then develop a variety in 1931. Obviously the farmers in that area knew about it way before 1931. Kentucky 31 was the variety that came out of that collection, released in 1943, and it was the dominant grass in the Southeast by the 1970s. I can remember as a child, after an ice storm, sledding down a long hill behind our house that was all tall fescue in the late 1960s. And if you calculate how many pounds of seed it would take to seed the Southeast from around that 1943 to 45 range, it is a staggering amount, and we'll go through that in just a second. That tall fescue was found on the Suter farm. In fact, for years, and then by farmers in that area, it was called Suter grass. And UK professor Dr. Fergus was doing a meeting there on, I believe, sorghum, and they asked him if he'd seen the Mr. Suter's grass. And he said he had not, but he would like to, because Dr. Fergus was a forage breeder. And when he saw the field, it was very different than most of the forages that you would see at this time of year. This is winter time, and it was green. Most of the other forages that we were growing at the time would have been brown, and obviously this was very different. This is another view of that same field and farm, and the Kentucky 31 was collected up here among the grove of trees at the top of the hill. I happen to have a copy of this photograph, the original, in my office, and there's notes on the back that said that that's where that seed came from. So let's talk about that seed exercise for just a minute or two. Tall fescue is widely adapted. We think there's 37 million acres. If you say there's 35 million acres and it takes 20 pounds of seed to seed one of those acres, that means somewhere between 1943 or 4 and 1968, when I was sledding down that hill, 700 million pounds of seed were produced and seeded in order to generate 37 million acres. 700 million pounds of seed. I may have said 700,000. That's 700 million pounds of seed. That's quite amazing. In fact, there is no other equivalent story like the tall fescue story. In fact, they've written a book. There's a recent book called The Wonder Grass, written by Don Ball, Gary Lacefield, and Carl Hovland, and it's a fascinating read. So, tall fescue's got the widest area of adaptation of any single species in the U.S. Kentucky 31 is the most widely grown variety. If you're going to buy seed, if you go to Lowe's or Home Depot and you buy a bag of tall fescue seed, it may be labeled Kentucky 31 tall fescue, but there's no restriction or no policing of the farmers and the process, so that the Kentucky 31 that we buy most likely isn't Kentucky 31, but it does most likely come from the state of Missouri. If it's improved seed, certified seed, or plant variety protected seed, it's going to be coming from the Oregon's Willamette Valley, which is a beautiful, beautiful place. And tall fescue is one of the only cool season grasses that will persist in grazed pastures throughout the southeastern U.S. Tall fescue is tolerant to cool and hot environments. It's grown from Florida to Canada. Another way of saying it's widely adapted. It is tolerant to poorly drained soils and flooding. And if you think back to the springs we've had over the past several years in Kentucky, and even intermittent floods in the middle of the year, it's very important that you don't have to reseed your pastures or hay fields. So fescue becomes a very important plant to you in that case. But I want you to be aware that tall fescue, and frankly any plant that adapts to flooding after the fact, develops a type of cell known as aerenchyma. These are hollow cells in the root that allow diffusion of oxygen in wetland plants. And by wetland plants, we mean plants that don't have an option. They're in the flooded area. And tall fescue is one of those plants. And those channels are formed by a couple of different mechanisms, but they will be like snorkels that let oxygen get from the air or the top of the plant into the root, down to the root tip, that growing part of the root, and it will also let carbon dioxide out. So they're very important, and tall fescue is able to then adapt to flooding conditions by developing aerenchyma cells, hollow cells. Tall fescue is more tolerant of drought than other cool season grasses, but I'm going to start introducing something here that we have mentioned before in the second lecture, and that is that the endophyte, the presence of the toxic endophyte, the wild type endophyte in tall fescue, gives it drought tolerance. And the presence of the novel endophyte also gives it some tolerance to drought and stress as well. Endophyte-free varieties did not persist because when they don't have the endophyte, they don't have that natural mechanism to tolerate drought and other stresses. Tall fescue is tolerant of poor soil fertility, low pH, and phosphorus, but at least in a limited number of studies that we're doing, it may not be very tolerant of low potassium, and we'll talk about that more a little later in the course. Let's talk about agronomic management for just a little bit, and if we're going to establish it, we're going to plant 15 to 20 to 25 pounds per acre, and I only mention seeding rates to help you do one thing, and that is to develop a sense of how expensive is something to seed per acre. The cost per pound of tall fescue, if you were to go to a vendor today, for the premium varieties, it'll be around $4 a pound, the novel endophyte tall fescues, and for Kentucky 31, it can be in the $2 range or even less per per pound. So if you use 25 pounds as the seeding rate, the highest one, that means the seeding rate can vary from maybe as low as $25 per acre if you got some super cheap Kentucky 31 type, up to $100 per acre. So there's quite a range in seed cost per pound, so per acre, per pound and per acre. Tall fescue has quicker germination and seedling development than bluegrass, and it's relatively easy to establish, although we will talk about in the next lecture our experience with tall fescue once we took the endophyte out. So you'd have to say again, the endophyte here interacts with seed quality and helps the plant be more aggressive as a seedling. When you talk about fertility for tall fescue, while fescue will survive on poor or marginal soils, it still needs adequate fertilization for optimal or good production. Tall fescue may be very competitive against legume species in the establishment phase, and in fact may inhibit germination and emergence and growth of interseeded legumes in extreme cases. The studies that have been done they're looking for, as this is known as allelopathy, where one plant is toxic on another, and you can see that go both ways. You can see it from grasses on legumes, and frankly you can see it on legumes having an inhibitory effect on some grasses. But since we are establishing legumes most often in an established grass, then we notice, and we need to take into account, that the presence of the grass and the decomposition products of the grass can be inhibitory to the development of clover seedlings. And therefore, you have got to then overcompensate to some degree by competition management, by soil fertility, by seed soil contact, all the things that you would do for good establishment. We just need to make sure it's really, really good for clover establishment in grass. Quickly, a little bit on hay and grazing management. If you're starting a new stand and you establish it in the fall, next spring cut it once for hay, and then after it gets up with some height on it, you may turning in to graze on it would be fine. That stand will still not have the tightness and the thickness of the sod that you may need to have should you have a lot of rain after you turn cattle on it. So be aware that it is still not going to be traffic tolerant, especially in wet conditions, even in that first year or two. So once you've gone to the trouble of getting in a stand, you're going to want to make sure that you're prepared to maybe move cattle around, keep them from poking up a new seeding. Established Kentucky 31 can tolerate some really high grazing intensities and can tolerate continuous or rotational grazing, and is tolerant to frequent defoliation. Now, maybe not frequent defoliation at an inch, but certainly having animals graze it a lot during the summer and fall and spring is going to be fine. Grazing tolerance and animal behavior is greatly affected by the endophyte type and presence, and that's what the next lecture is going to be about. And tall fescue is the very best grass for fall stockpiled pasture, and we'll talk about that. Tall fescue produces a high yielding and I'm going to say moderate quality hay. It can be excellent nutrition, but yet that second bullet there is not in very high demand as cash hay. The nutrition is going to be good if we're harvesting it at that late bloom to early heading stage. Cash hay is a very subjective, or demand for cash hay is very subjective. First of all, for horses, tall fescue, because of the endophyte, can be a non-starter. It can be a bad choice. But also just we call it the organoleptic qualities, the way it looks, the way it feels. Tall fescue is going to feel more coarse for the most part than orchard grass, which I would say is one of our grasses in most high demand as cash hay. And tall fescue tends to be a bunch grass when it's grown for hay. In grazing systems with frequent defoliation, we can get stimulation of tillers formation and rhizome production such that the clumps tend to grow towards each other, but if they were very far apart to start with, it's going to take a long time. A little bit about forages and what makes them different. It's how erect they are and what is their ideal height for grazing. From left to right, bluegrass, orchard grass, tall fescue, and Bermuda grass. Bluegrass and Bermuda grass can tolerate lower grazing than tall fescue and orchard grass. And if you had to say the most sensitive to close grazing, it would be orchard grass, followed by fescue, bluegrass being third, Bermuda grass being short. In fact, once Bermuda grass adapts to the cutting low, the stolons go out and the leaves emerge right at the soil level, and you can cut it down sometimes to an inch or half inch when you're talking about Bermuda grass turf. That cutting height regime would not do well for any of the other three. Let's finish this lecture by talking a little bit about stockpiling tall fescue. Stockpiling is the deferring of grazing in late summer and fall to allow enough accumulation of forage to provide grazing during the winter when things aren't growing. Tall fescue maintains more of its yield and nutritive value during the winter months than other cool season grasses or legumes. It doesn't say that here, but tall fescue resists the weathering damage that's really obvious on bluegrass or orchard grass. Stockpiling procedures in Kentucky look like this. Remove the cattle in late July or August. Make sure that you've left some residual there throughout the season. If you have hammered that field or the field to be stockpiled in the summertime, then it doesn't matter when you're going to pull off in late July or August, it's not going to grow back very much, even if you apply nitrogen. We get into a discussion or basically a quandary every fall, which tends to be dry in Kentucky, about whether we should put out nitrogen or not for stockpiling. And it's a hit or miss kind of a thing. But last year, in 2019, we had one of the hottest and driest falls in a long time. And we had a plot of tall fescue where we caught it just before rain in mid-August and put the nitrogen out, and were able to get substantial yields even after we had 45 days of basically very close to 100-degree temperatures and no rain whatsoever. Once it did start raining in October, the grass came on and yielded, you wouldn't say perfectly, but it yielded well enough to be of a benefit to you. When we start to graze that stockpiled tall fescue, we can stretch it and make it last if we'll just allocate it in strips. The nice thing about, the convenient thing about strip grazing stockpile tall fescue is you don't have to back fence it, because it's not going to grow back as long as the animals aren't poking up those fields. You just move the fence progressively through a field and let them have a new strip over time. Allocating 3 days worth of supply versus a week's worth will add the equivalent of 40% more grazing days for cows. And it comes because they don't waste as much. They don't lie down on it. They don't defecate on it. So they wind up eating more of what you allocate. The typical benefits does vary, and there's a lot of discussion back and forth about what the economic benefit and the cost return is for stockpiling. But it's a lead pipe cinch that if we are able to get some growth in the fall, we are out the nitrogen cost. That is true. We are out the deferment of the pasture, so we didn't graze that pasture, but it will reduce the number of days you have to feed hay. The number of days that you save will vary by year. The cost per cow can be estimated for feeding hay at about $1.20 a day for a cow, and with good yields and decent years, the cost per feeding a cow per day with stockpiled tall fescue out of pocket is about 40 cents a day. And we'll just make the point, you got bluegrass in the red and you got tall fescue in the blue, that tall fescue is a better stockpiling grass than bluegrass. The yields here, at least the shape of the curves, are similar, the yields are higher in magnitude for tall fescue than bluegrass. And you can see that there is growth from October to November. The slope of the line is positive. From November to December, basically there is no change in the yield. So by that time, we've gotten cold enough that the growth has stopped. And then we begin to see decline in those stands due to weathering. But in all cases, tall fescue is able to maintain more yields in the fall than bluegrass. This is a graph that I need to qualify just a little bit. This is in vitro dry matter digestibility on the vertical scale between 70 and 90%. And in the horizontal scale is the days of accumulated regrowth. So what they would do is to stockpile tall fescue and stockpile orchard grass, and then come in at 30 days of accumulation, then about 68 days and about 105 days, and take samples and measure the in vitro dry matter digestibility. And you'll see that for both species, they decline from their highest point 30 days after accumulation, or after accumulation starts, down to their lowest point towards the end. If 30 days after you started is September 15th, then 90 days later would be December 15th, which would be about the right-hand end point, or not quite 90 days. So the weathering that occurs does reduce the quality. The qualifying I have to do is that the vertical scale for IVD&D goes from 70 to 90, and that is exceptionally high for grasses. And in fact, you'd have to say that these were absolutely green, leafy, fresh tissues to be this high in vitro dry matter digestibility. Typically, fescue will start out in the 65 to 70% digestibility range in the beginning of the stockpiling season. But the curves and the magnitude of the drop and the differential in yield, they're absolute, or differential in quality here, are absolutely consistent with what we know. So if you're going to summarize tall fescue, it's adapted to a variety of soil and climatic conditions, even flooding. You can use it to extend the grazing season. It is the best grass for stockpiling. It has good yield and good persistence. In fact, farmers expect tall fescue to live, in their words, forever. It has pretty high carrying capacity. That's a reflection of total production per acre. And it is more resistant to treading after it's established than most any other grass. Disadvantage is going to be tall fescue toxicosis. Tall fescue toxicosis is caused by the endophyte of tall fescue, which is something you've probably heard about. We will spend at least one lecture talking about what that is, what that means, and what the endophyte causes in tall fescue and in the livestock that consume endophyte-infected tall fescue. It can be overly competitive with legumes, but manageable. And the hay generally doesn't have the greatest of textures, which affects the cash hay market. But it doesn't affect whether a cow will eat it or not. So, with that, we are at the end of this lecture. Thank you for your attention, and we will see you next time.